Well, hello there again. This is Mrs. Becky Reed, and today I'm going to be going over IXL section R13 in pre-calculus, and we're going to be talking about those trigonomic ratios and using them to find a missing angle measure. Um, Specifically, we're going to use the special triangles with their exact values that we discovered with the unit circle recently. And we're also going to use some decimal values, but we're going to be using the calculator for that. And I am specifically going to show you how to use the TI-84 plus graphing calculator. So far, what we have done is if we have a right triangle, such as this one right here, and we have the angle degree, then using the different side, we can find a missing side length. So um, if we have the sine of the 35-degree angle here, which is the opposite, um, 2.8 right here, over the hypotenuse, which is 4.9. But if we didn't know that, and called it x, we could then set up our equation like I have here and then do all the calculations and solve for it, and then it would then give us that side length. So that's what we have previously done. So if we are using this right triangle as an example, say we didn't know what the degree of the angle is there, you would set up your problem like this. The sine of angle x is equal to the opposite side over the hypotenuse. Then that will tell us the angle is what we're looking for. And now the thing that we would do is we would use this notation here, and that is a different way of saying it's the inverse of the sine angle. So another way of reading this would be the angle whose sine is 2.8 over 4.9. You would pop that into your calculator and it would spit out the degrees. That's a 35-degree angle. So let's jump in here and look at example one. They want us to find the measure of angle R. That's this one right here. Okay, so from that angle, we have the adjacent leg, um, which is square root of 21, over the hypotenuse, which is the square root of 42. Right? So what that is the adjacent, I'll just write that, adjacent over the hypotenuse. So that is a cosine angle there. All right? In a cosine ratio. So the first thing we're going to want to do is to reduce that. So that's going to reduce down to square root of 1 over, whoop, 1 over the square root of 2. Okay, if we take that a little bit farther, square root of 1 is 1, and we cannot simplify that one anymore. Now we are looking for the inverse to find the degree. Now, if you notice, we're dealing with the radicals and we want an exact value. So over here, if you go to these values of the unit circle, they're all listed out. Here's our 30-degree angles. Here's our 60-degree angles here. And then we've got the 45-degree. So we've got all those ratios there. So if we're looking for which angle has a 1 over the square root of 2, well, these values here, they've had their denominators rationalized, which means, again, there are no radicals in the denominator. So we're going to have to fix that. And again, we do that by multiplying it by itself. What you do down in the denominator, you have to do in the numerator. So up here, we have the square root of 2 over 2. Okay, now we can match that up. And we can see that that is a 45-degree angle that has that value. Um, so that's going to be 45 degrees. And see how we've just simplified this, reduced it, and then rationalized the denominator. And then you just simply have to look at the chart here to see which one it is. So I've also given you in your notes a chart that looks like this. It's just laid out differently. You can print this off and use these if you want to, but it's got the sine, cosine, tangent, but this also has the inverse of those ratios, cosecant, secant, and cotangent. And then you could have just found the value there if you wanted to do it that way. All right, in this next example, they want us to find the measure of angle D. So that one's right here. All right, we notice that we have the adjacent leg. So we have that one, and we also have the opposite over here. So adjacent and opposite is going to be a tangent ratio. So we can say we're looking for the the angle of measure D, or actually this out. All right, so the measure of an angle that has a tangent of opposite is 40 square root of 3 over the adjacent is also 40 square root of 3. And that reduces down to 1 over 1, so that's pretty easy. There. That equals 1 over 1, which is just 1. So the tangent of that angle is just 1. So we will look over here, which one has a tangent of 1, and that also is a 45-degree angle. Um, so the angle that has a tangent of 1 is a 45-degree angle. Now, if you also had noticed that both of these legs are the same length, we know that the triangles that have the same length also have the same degree, which is a isosceles triangle. All right, this next problem, problem number 3, we don't have radicals here, so we're not going to be using a special triangle. I'll get rid of that. So we're going to actually use our calculator for this one. I use a TI 84 Plus, which is allowed on the ACT and the SAT. So it's a good idea to know how to use it, or else it'll slow you down. Just not knowing your calculator is going to slow you down if you don't know how to use it. And you can't use your phone on any of those as of the recording of this video. Okay, so we're looking for the measure of angle I, this one right there. All right. And what we notice is that from measure of angle I, we have the adjacent leg, adjacent, and we have the hypotenuse. Right, so the adjacent over the hypotenuse is a cosine ratio. So the angle whose cosine of angle I equals the adjacent is going to be 6.9 over the hypotenuse is 9.5. So this site has a simulated calculator that we're going to be using. I'm going to show you how to use it on here. So the first thing you always want to do is look right here where that says radian. You to do these problems, we want to have that to say degree. So we're going to go over here to this mode button, hit mode, and then we go over here to scroll down and scroll over to highlight degree and press enter. To get out of this screen, you're going to hit second because when you hit the second, these blue keys are being used. So second, mode, or quit, and that's going to get you where you want to be. All right, we said that we had a cosine. And if you notice, if you hit the second blue button again, it's going to give us those inverse functions, ratios. So I hit second, I'm going to go to cosine, and it brings that up. Now, what you can do, I'm just going to show you the easiest way, is most clear way. If you hit alpha and then this Y button, and it brings up these different ways to use these fractions I showed you before. This one is already highlighted. I hit enter, and it brings up those boxes for fraction. So I'm going to type in the numerator 6.9, and then I'll go down the denominator 9.5. Now I'm going to go over, and I'll close the parenthesis and hit enter. And what that does is it gives us that it spits out the angle. But now watch this. I'll show you what happens if you're not in degrees, you're in radians. So we'll get out of that. Now, here's another little trick. I don't have to type all that again in this calculator. I can go up and highlight that, hit enter, and it grabs the whole thing again. I don't have to type it again, which wastes time if you're on a time test. And I will hit enter, and see, you notice the different answers here. That's because you're in radians, and we are working in degrees there. All right, so that calculator gave us equals a approximately 43.4 degree angle, and IXL wants you to round it to the 10th place. Okay, so this is that website right here. Um, this is for the simulated calculator, and this is what it's going to look like when you pull it up. And a lot of times you just have to like downsize that, the ads and things like that. And if it doesn't show the whole calculator, let's see if I scroll. If I scroll, it brings that back up. You can make it smaller using this. You can zoom out and then hit enter, and then you're good to go. And as you can see, it's brought up radians again. So I will go to the mode. I'm going to go down radian over to degree, hit enter, blue second, the mode quit button, and then you're good to go with that. All right, so for problem number 4, go ahead and pause the video and go ahead and try this one on your own using that calculator. And I'll be back in a minute. Oh, it is recording. Okay, my bad. So hopefully what you would have gotten is it's the sine whose angle um is 4/7. So you set it up like that, and then we'll put that into the calculator. So we will just type that in. We want to do, we're already in degrees, so second, sine, right? Sine. And I don't think you have to bring up the fraction box if you don't want to. So I'm gonna do it like this. 4. Another way to show the calculator that something is a fraction, you just do divided by 7, and then you close the parentheses. So this is how many calculators have to treat a fraction, but they do have to be in parentheses to tell the calculator that it's a fraction. Oh, you know what? Look here, it didn't bring up the inverse. So let's clear that out. Second, sine. There we go. See, I caught that mistake. We're going to do 4 divided by 7. Close the parenthesis. Enter. And so that's just a different way of putting your fraction in. And then it gives us 34.84. All right, it gave us a measure of 34.84, and they want that rounded to the nearest tenth, which is going to just be 34.8 degrees. Way to go. Right on this next example, what we see that we have radicals here, but those don't really reduce down into one of those special triangles because not everything with a radical is going to be a special triangle. So we can go ahead and set up this problem, and we are looking for the measure of angle y, which is this one, but you can just see it because the screen cut it off. That's y. All right, so let's see what we have here. We have an opposite here, and we've got the hypotenuse because it's right across the street from the right angle. So opposite over hypotenuse is going to be a sine ratio. So the angle whose sine, let's see, measures y is, opposite is square root of 29 over square root of 71. Now, I'm about to show you something that you'll probably use now forevermore with these. Well, no, you really can't. Never mind with these radicals. But anyway, hang on. All right, so I'm just going to go ahead and put that in the calculator. Second, we're doing a sine, right? And see, it didn't do it for some reason. Let's try that again. Second sine, there, it did it. I'm going to go ahead and do the fraction box because it has these radicals and it's just going to be a lot easier. All right, so we need, in the numerator, we have the square root of 29. Now I'm going to go down, and second square root of 71. Go over, close that parenthesis, see what we get. 39.72. All right, so the measure of angle y we found to be 39.72, but again, they want you to round to the 10th place, so that's going to be 39.7 degrees. Okay, why don't you guys go ahead and pause the video and try this last problem by yourself. All right, so hopefully you set your problem up like this. We're looking for the measure of angle x up here. I have the adjacent and the hypotenuse, which is a cosine function. Again, we are looking for angle whose measure is square root of 59 over square root of 93. Go over to your calculator and let's just type that in. Let's see, we're second cosine. See, it did it again. I don't know why. I'm glad I double checked. You get the wrong thing. Let's see. There we go. I'm going to bring up a fraction box. And let's see, we have square root of 59. Go down, square root, 93. Go over again, close the parenthesis, enter. And I got 37.2. So like I said, we got 37.2 degrees. And that's really all there is for that one. Hope that made sense. Let me know if you find any errors, and I will see you next time.